Hello, hello, hello! Today I am the Math Train, and today we're going to be doing the power rule for derivatives. If you don't know what the power rule is, I'm going to teach you, and we're going to do several examples, and then after that you should be able to understand how to use the power rule to find the derivative or the equation to the slope of the tangent. And if you don't know what that means, please check out my last video, the derivative function. Moving on, so I have the formula right here. And let's move on. The power rule. F of x equals x to the power of n. Then the derivative of that equals n as a coefficient x to the power of n minus 1. And we're going to be doing x to the power of 1 through 10 today. Okay, so I've been using the formula for a few times. Let's do 2x. I brought down the 2 to the front as a coefficient, just like in this. I did 2 minus 1, just like this. And I was left with 2x. Moving on, you should be picking this up quickly. Okay, so that was x to the power of 1 through 10. I circled all the answers. If you're starting to pick up on it now, I'll explain a few examples. So I brought the 3 down to the front as a coefficient, and then I did minus 1, and then I got 3x to the power of 2. I brought the 4 down as a coefficient, and then I did minus 1 for the exponent, and I got 4x to the power of 3. I brought the 5 down as a coefficient, minus 1 for the exponent, I got 5x to the power of 4. 6x, I brought the 6 down, minus 1 to the exponent, I got 6x to the power of 5. I brought the 7 down as in a coefficient to the x, and then I did 7 minus 1, and I was left with 7x to the power of 6. I brought the 8 down as a coefficient to x, and I did minus 1 for the 8, and I was left with 8x to the power of 7. And then by then, the more practice you do, the more quicker you'll get at it, and you can do it all in one step. Like just by looking at these, you can convert to these. And I should have put a disclaimer. I'm just going to do a disclaimer now. If you can pick up and understand how to do each one, I suggest pausing the video and going through each example. I'll let you pause right now if you want to do all of the examples by yourself. If you have a coefficient and you bring the exponent down, n, or you bring n down to the front as a coefficient, you multiply both the coefficient and the exponent that you bring down. So that's what you do if there is a coefficient. If you want to pause it and do them on your own, let me know, or you can just go ahead and do it. I'll also show you these ones if you want to pause and do it on your own. Give you a few seconds there. And then there are these ones if you want to pause and do it on your own. And those are the last questions that I have there. Okay. So for those who need instruction, let's begin. Okay, let me explain those two examples. So I brought the 4 down. I multiplied the 8 and the 4 together to get 32. I did n minus 1, which resulted in 3. Okay, I brought the 6 down. I multiplied it by the coefficient. I got 30. I did 6 minus 1 to get 5. So I got 30x to the power of 5. And I got 32x to the power of 3. Okay, I'm going to save all my explanations for the end. And hopefully you'll be able to understand. If you want to just look and watch what is happening and try and figure out the steps on your own, or if you want to wait for the explanation, that's okay too. Whatever learning style works best for you. Okay, I'm going to start explaining now. I'm going to use my lightsaber tool to explain. So, I brought the 5 down to become a coefficient with x. I multiplied them together to get 45. I have x, and then I have 5 minus 1, which gives me 45x to the power of 4. I brought the 7 down, and I multiplied it with the 6 to get 42. And I did 7, or n, minus 1 to get 6, and I was left with 42x to the power of 6. These ones I did quickly. You might need to space it out and do more steps in between before you get the final answer, and that's completely okay. You take as many steps as you need, but the more practice you do, you should be able to do it with your eyes closed to add a metaphor in there, or all in one step. All in one step probably makes more sense. So I brought the 3 down to become a coefficient with x, and then did 3 minus 1, which was 2. I brought the 2 down, I multiplied it with the 7 to get 14, and then I did n minus 1, so 2 minus 1, and then I got just 14x, and then I did, whenever you just have one x there, you get rid of that x, and you're left with a constant, aka just a number. So I did minus 8x becomes minus 8 when we're determining the derivative. I brought the 5 down, I multiplied it with the 4 to get 20, and then I minus 1 from 5 to get to the power of 4, so 20x to the power of 4. I brought the 4 down, I multiplied it by the 3 to get 12, and then I minus the 4 minus 1 to get to the power of 3, so 12x to the power of 3. Again, when you just have something like 9x to the power of 1, you get rid of that x, and you have a constant of whatever is left. For in this case, plus 9x would be plus 9. I have 2x to the power of 5 plus 5x to the power of 3 plus 3x to the power of 2 plus 4. If we have a constant, the constant derivative is 0, which I will be covering in a separate video, or it was covered in the first video, and you can go check that out as well if you would like it, the derivative function. I brought 5 down, I multiplied it with a 2 to get 10. I minus 1 from the 5 to get to the power of 4. I brought the 3 down, I multiplied it with the 5, and then I minus 1 from the 3 to get to the power of 2. I brought the 2 down, I multiplied it with the 3 to get 6x, and when it is to the power of 2, you just get rid of it, and it's x to the power of 1. I hope that made sense. There was a lot of explanation in a short period of time. If you would like to go back and slow it down to 0.75 speed, you are free to do that if you wish. But moving on. Okay, so I have f of x to the equals 1 over x, and you may be thinking, how do I solve this? We're going to use our negative exponent rule, bring the x up, and you're going to have x to the negative 1. And now you can solve it. So we're going to find the derivative. We're going to bring the negative 1 down. We're left with x negative 1 minus 1. And we are left with negative 1x to the power of negative 2. And we can't have negative exponents on the top. So we're going to get rid of that x that I just wrote there. We're going to do negative 1x to the power of 2. And then we're left with negative 1 over x to the power of 2. And that is our final answer, and that's circled right there. We're going to do this again, and now it's going to be 1 over, f of x will be 1 over x to the power of 2. We're going to bring the x up, and we're going to do x to the power of negative 2. And then we're going to find the derivative using the power rule. We're going to bring the negative 2 down to become a coefficient with x. We're going to do negative 2 minus 1, and then we're going to do negative 2 x to the power of negative 3. We can't have positive exponents. We can't have negative exponents on top, so we're going to do negative 2. We're going to bring the x backs down, and we're going to have negative 2x to the power of 3. Negative 2 over x to the power of 3. Sorry about that. And now we have a super duper complicated rational function, and we're going to try and find the derivative of it. AKA, we just have a higher exponent and a coefficient on the top that is not 1, so it's going to be beside that coefficient. And let's begin. So we're going to bring the x to the power of 4 up. It's going to become a negative exponent. And then we're going to bring the 8 down. We're going to have that 8 there. We're going to bring the negative 4 down. I'm sorry. And then we have x, negative 4 minus 1. Okay, and then we have negative 32, because 8 times negative 4 is negative 32. And then we have negative 4 minus 1, negative 5. And then we have negative 32 on the top. We're going to bring the x down to the power of 5. And we're going to bring it down on the underside. So basically, we use our negative exponent law lots when we are doing rational functions and using the power rule to, and we're using the power rule to find the derivative of rational functions. But there is an easier way. It's called the quotient rule, and we're going to cover the quotient rule in another video. And once we cover that video, you'll know how to do those questions very easily. But that's how you use the power rule to do rational functions and find the derivative or the slope of the tangent for the rational functions. Okay, moving on. And now I have square roots involved, and you may be thinking, I don't know how to deal with these square roots, but it's just a different way of thinking of it. We are going to use, I forget which law it is. Give me a second. I think it's the rational exponent law. Yes, it is the rational exponent law. It's when we have a square root in there. And we're going to use the rational exponent law. So the second root to the power of 1 is just the square root of x. And guess what? Square root of x is just x to the power of half, or 1 over 2. And now that we have that, we can find the derivative using the power rule. Okay, so let's explain what we just did here. The square root of x is just x to the power of 1 over 2. We brought that 1 over 2 down to become a coefficient with x, and then we multiplied 1, and I switched it to 2 over 2, because I noticed that we had 1 over 2, so I wanted common denominators so we would know how much to subtract from and what the fraction or new answer would be, or result would be. And then I was left with negative 1/2. And because, so half of an x, you can write it like this, or you can write it like this. Okay, sorry about that. I just needed a minute there. And then I have a negative exponent on top, so I'm going to bring that negative exponent to the bottom. And then remember, x to the power of half is just the square root of x. And this is the simplest form, or the proper answer. 1 over 2, the square root of x. Okay. Okay, so the number that appears by the square root symbol is the number on the bottom. So we have x 5 over 3. Okay. So, we're going to use the lightsaber tool. The number near the square root is the denominator of the fraction. The number outside the bracket is the numerator of the fraction. So, the cubed root brackets to the power of 5 is x 5 over 3, or x to the power of 5 over 3. And to find the derivative, we brought that exponent down to become a coefficient with x. We minus 3 over 3 because the denominator is 3, and I wanted common denominators when we're subtracting between fractions. And I got 5 minus 3, which left me with 2 over 3. And the 2 over 3 was positive, so I left it on the top. And underneath, I put 5 over 3. And then our final answer was 5, bracket, the cubed root of x, bracket again, to the power of 2 over 3. And we're going to move that 3 to the middle just so it looks nicer. Okay. So the derivative, 15x2 plus 8x1 plus 5. Hold on for a second there. Just circling my answers. Okay, so I brought the 3 down with the 5. I brought 3, multiplied it by 5, I got 15. I did 3 minus 1, which left me with the exponent of 2. I brought 2 down, multiplied it with the 4, I got 8. X, 2 minus 1 is 1. I left that without an exponent there, because to the power of 1, you don't need an exponent. I got 5x, and then I crossed out the x. I don't need the x anymore, and I was left with a constant of plus 5. Moving on. Last 2 questions. So I got half x, and then I got negative 12x to the power of 3 using the power rule. And I'm sure you understand the power rule by now because you're really smart at math, and you're putting in the effort to look at math videos and learn from them. So kudos to you for taking advantage of the education that you have, and just I'm sure that you're really good at math, so don't stress out when you have tests or exams or anything. Once I enter university, I'll be doing a video on tips for university students, and I should probably work on a video for tips for high school students. So those 2 videos should be coming soon, and thank you very much for watching, and I hope you have a wonderful day.